Hello class, welcome to another video for the course. In this video we are going to study section 7.2 which is about addition and subtraction identity. So we are focusing on trig identities in this section, and we will see the application of these identities. So the first set of identities that we would like to discuss is the sum and difference identity, which is the sum and difference of angles. So as you can see here, we have, for example, cosine of the difference of two angles. Your textbook named them alpha and beta. So suppose you have a cosine of the difference between two angles, or cosine of the summation of two angles, or sine of sum and difference of angles. So there are formulas that you can expand them. For example, if you have cosine of the difference of two angles, that is equivalent to cosine of the first angle, cosine of alpha, times cosine of the second angle, plus sine of alpha, sine of beta. Or if you have the sine of summation of two angles, it's going to be the sine of the first times cosine of the second angle plus cosine of the first times sine of the second angle. To see how these identities holds, you can there is a proof of which one? For cosine. Yes, in your textbook there is a proof for the cosine identity. I encourage you guys to read over this proof to see why this identity hold. So as you can see, the final result is that the cosine of difference of two angles is cosine of the two angles, the product of the cosines plus the product of the sine. And then similarly, you can prove the rest. You can prove the rest of these identities. But our focus here is the application. So we are not too much concerned about the proof of the identity. Instead, we want to see how can we use these identities in order to solve problems. For example, in the first question says, find the exact value of cosine of 75. Okay. So for cosine of 75, so this is example 1. And the question is find the exact value of cosine of 75. So I'm not gonna use calculator because we want to find the exact value. Instead, we can rewrite a cosine of 75 as cosine of 30 degree plus 45 degree. And why do we do that? Because we know the cosine of 30 and 45 degree. So if we can use one of the identity in order to rewrite this in terms of cosine of 30 and 45, then we will be done. So now we have what do we have here? We have the cosine of sum of two angles. This is the sum of 30 to 40 degrees. So I'm going to use the sum identity for cosine. Look. So we want to use the sum identity for cosine. So if you have, so it's going to be the second identity. If you have cosine of the summation, it is the same as cosine of the product of the cosine of those two angles minus the sine of those two angles. So this is going to be the product of cosine of these two. So cosine of 30 times cosine of 45. And then what is it here? It's minus. So then minus sine of these two angles, sine of 30 plus, product multiplied by sine of 45. So here I just applied the sum identity. So here I just applied the sum identity for cosine. And the rest is just, we know what is the cosine of 30. We know what is the cosine, for example, cosine of 45 is square root of 2 over 2. Sine of 45 is square root of 2 over 2. Sine of 30 is half. and cosine of 30 is square root of 3 over 2. Because we know the exact value of these basic angles, that's why we can rewrite them in terms of exact value, and the rest is just simplifying. So you can simplify this in any way that you want, or you can leave your answer like that. I think, yeah. So let's take a common denominator. Yeah, so the textbook simplified it this way. Yeah. So take a common denominator. Here we get, so no, sorry, this becomes square root of 6 over 4. This becomes the square root of 2 over 4. So the answer is square root of 6 minus the square root of 2 over 4. But the point was that because we wanted to find the exact value of cosine of 75, we rewrote 75 as a summation of two known angles, and then we used the cosine sum of angle identity. And then we evaluated, and then we simplified. Let's look at another example. The question is to rewrite this sine of x minus pi over 4 in terms of sine and cosine. So example 2 is rewrite sine of x minus pi over 4. So we want to rewrite this in terms of sine and cosine. Sorry, in terms of sine of x and cosine of x. So we don't want to see the pi over 4. We want to rewrite this in a way that we only see sine of x and cosine of x. So what do you see here? Here we see a difference. You see the subtraction? So this is a difference angle, the difference between angles, right? Difference angles. So here we can apply the difference angle for sine. So look at the identities. So here are the sum and difference identities. Pick the difference for sine. So it's the last one. The difference identity for sine. So here I'm going to apply the difference identity for sine. So sine of, so it's going to be sine of difference of two angle. It's going to be sine of the first times cosine of the second. So it's going to be sine of first times cosine of the second minus cosine of the first times sine of the second angle. Okay, so I just applied the last identity over here, the difference identity for sine, which says that when you have sine of the difference between two angles, it is the same as sine of the first angle times cosine of the second angle minus cosine of the first angle times sine of the second angle. So now, because we know the sine and cosine of pi over 4, so we can evaluate them. So cosine of pi over 4 is the square root of 2 over 2. Sine of pi over 4 is also square root of 2 over 2. That's it. But if you like to simplify it, you can also factor a square root of 2 over 2. From the first, you end up with sine of x. From the second, you end up with cosine of x. That's it. So as you can see here, we wrote, as you can see here, we rewrite sine of x minus pi over 4 in an expression that only contains sine of x and cosine of x. Okay, so sine, it only contains sine of x and cosine of x. Okay, now let's look at example 3. It says prove this identity, prove this equation. On the left, we have so on the left, example 3, we have sine of, it's a fraction, numerator is sine of a plus b denominator is sine of A minus B equal on the right side, sorry, on the, yes, on the right side, we have tangent of A plus tangent of B on the numerator, and denominator is tangent of A minus tangent of B. So we need to prove that this holds, this equation holds, this identity holds. So we can either start from the left, start simplifying, or start from right, because we just learned about the sum and difference identities. Let's start with left side, because on the left side, on the look, you have sine of A plus B over sine of A minus B. So we can use the sum and difference identity. So look, what was the sum and difference identity for sine? So when you have the summation of two angles, it's going to be sine of first times cosine of the second. So it's going to be sine of first times cosine of the second plus cosine of the first times sine of the second angle. Okay. Denominator is the difference. When you have the difference of two angles, sine of difference of two angles is the sine of first. So the order is the same. Sine of first, cosine of the second, cosine of the first, sine of the second. But the difference is that here, because you have difference in the identity, also you have subtraction. So it's going to be same as numerator, sine of the first times cosine of the second, but minus cosine of the first times sine of the second. So here I just applied the sum and difference identity. So far I don't see any, I mean, I don't know how to, it's not clear how to move forward to get tangent. So I'm going to stop at this step and start simplifying the right side. On the right side, we have tangent of A plus tangent of B over tangent of A minus tangent of B. Because on the look, what the sorry, because okay, so this term contains tangent. The left, the expression on the left contains sine and cosine. So it would be better if we rewrite tangent in terms of sine and cosine. We know that tangent is sine over cosine. So I'm gonna rewrite each one of these tangent as sine. For example, tangent of B is sine of B over cosine of B. Again, sine of A over cosine of A minus sine of B over cosine of B. Okay, so how can we go further? Here, this is gonna be, we can take a common denominator, right? The common denominator here is gonna be cosine of A times cosine of B. Here, this is gonna be sine of A times cosine of B plus cosine of A times sine of B. What about here, denominator? Take the common denominator. It's going to be cosine of A times cosine of B. And then on the top, we should have sine of A times cosine of B minus cosine of A times sine of B. Okay, now we can cross these two, and that's it. So we end up with, look, so we end up with sine of A cosine of B plus cosine of A times sine of B over sine of A cosine of B minus cosine of A times sine of B. So now look, we simplified. So what did we achieve here? We started simplifying we started simplifying the left side and we got this fraction. Then we started simplifying the right side, the expression on the right side, and we got to this point, and they are the same. You see, these two are the same. So that proves that this identity hold. Okay. So in other words, we simplified both left and right side of this equation, and we end up with the same expression on either side. So that proves that this equation hold. Okay, let's look at this question. This is a good one. You have an equation. You're given an equation that contains trig function. The question is solve it for x. Let's see how can we use identities in order to solve equations. So this is example 4. The equation is sine of x times sine of 2x. And plus cosine of x times cosine of 2x equal square root of 3 over 2. The question is solve it for x. Solve it for x. In other words, find the x values that satisfy this equation. So, okay, in this equation, on the right side, I just have a number, square root of 3 over 2. But on the left side, we have a combination of sine and cosine function. Let's see if we can use any identities. So what do you have here? You have sine multiplied by another sine plus cosine times another cosine. So look at the identities and see which one of the identity resemble this one. It's a product of two sine. So here I have the product one more time. It's the product of two sine plus product of two cosine. So it's the first one, you see? In the first identity, you have the product of two cosine plus product of two sine. So this can be written as the cosine of the difference of those two angles. So this can be written as the cosine of difference of these two angles. What are the two angles? One angle is x, the other one is 2x, and this is the same as the difference. So we use the so here we just apply the difference identity for cosine, because the difference identity for cosine says that the cosine of, when you have the difference of two angles, x minus 2x, can be expanded as that the product of two sine, the product of sine of those two angles plus product of the cosine of two angles. Okay, now we end up with much simpler question. X minus 2x is going to be negative x, right? So now the question is, what is the x value that the cosine of negative x is square root of 3 over 2. So please remember that cosine is an even function. So any even function, for any even function, cosine of negative input is the same as positive input. So cosine of negative x is the same as cosine of x because the function is even. So I'm going to rewrite cosine of negative x as cosine of x. Okay, now the question is that what is the x value, or in other words, x is the cosine inverse of square root of 3 over 2. right? So for what angle you get that? So that's gonna be pi over 6. Um, is there any limit? It's all the product of, it's pi over 6, and I'm just wondering if there is a restriction. No, there is no restriction. So it's gonna be all of this. Look, square root of 3 over 2. Look at the unit circle. So for pi over 6, right? This is the cosine, which is square root of 3 over 2, right? So pi over 6, x is gonna be pi over 6. What else? And also this angle also has the same cosine. This is negative pi over 6, right? Negative pi over 6. So it's gonna be 2 pi minus pi over 6. It's gonna be 11 pi over 6. So it's gonna be 11 pi over 6, and so on. Because, you know, this is in the first rotation. You get these two answers. But in the second rotation, it's going to be 2 pi plus pi over 6, which is again right here. So it's going to be 2 pi plus pi over 6 in the second row, and so on, right? So there are infinitely many answers. If you want to know the general format, it's going to be 2k pi plus pi over 6. It's right here. The general format is pi over 6 plus, so the solution is all of these angles and these angles. So if you don't restrict that, it's going to be in any rotation. So this is what? This is pi over 6. Then if it's on the first rotation, so it's just pi over 6. But then it could be in the second, third. So in general, we put 2k pi. Depends on what rotation it is. And here, this is going to be 11 pi over 6 plus 2k pi. And k can be any 0, 1, 2. K is an integer. Okay. So the point was that, the point is that here we used an identity, a difference identity, and that helped us to solve this equation and find the solution to this equation. Okay. So now let's look at example 5 that says rewrite this function as a sum of sine and cosine. So the function given, the function is given in terms of a single sine, right? But it says to rewrite this in terms of a summation of sine and cosine function. So let's see. Example 5, f of x is what? 4 sine of, the angle is 3x plus pi over 3. 3x plus pi over 3. Okay, so because look at the angle, what do you see here? This is a summation. You see, it's 3x plus pi over 3. So here you have sum of angles. That tells us we can use the sum identity. Okay, so here I'm gonna apply the sum identity for sine. So it's gonna be sine of, the summation of two angles is the sine of first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. Now, let's evaluate. Sine of 3x, cosine of pi over 3 is half, and sine of pi over 3 is square root of 3 over 2. That's it. So you see, if you want, we can simplify further. So for example, this by this is going to be 2 sine of 3x plus square root of 3 over 2 cosine of 3x. But the point is that we end up with an expression. So we rewrote the function in a way that it's based on sine and cosine function. So we rewrote it as a summation of sine and cosine function. Oh, I forgot this 4. I'm sorry. When I, this 4, when I multiplied, sorry, I don't know what happened to my whiteboard, but this 4 needs to multiply by each one of these terms of the summation. So when you multiply that 4, here you get 2, here also you get 2 square root of 3. But my whiteboard is gone. Okay. What else? What else matters here? Okay, so I think we saw enough examples of the sum and difference identities. Now let's look at another set of identities, which is product to sum identity. What does it mean? It means that you have the product of two trig functions. For example, product of sine and cosine, or product of two sine, or product of two cosine. You see that? So you have the product of two trig function, and then we are able to rewrite this as a summation of two trig function. For example, suppose you have the sine of an angle times cosine of an angle. It's the same as sine of the summation, it's half of the sine of summation of those two angles plus sine of the difference of those two angles. So why this is good, why this would help us, because look, on the left side you have two functions, sine and cosine, but then on the right side we are able to rewrite it as only in terms of sine. Or for example, or any of them. So the point is that in these identities on the left side you have a product, right? You have a product of two trig function. Then using these identities we are able to rewrite that expression in terms of summation of trig functions rather than product, and sometimes that would help to solve problems. For example, look at, just to have a warm up of on these identities, look at the example 8. We have the product of two sine functions, sine of 2t, sine of 4t. And we want to rewrite it as sum or difference. Example 8. So it's sine of 2t times sine of 4t. So it's the product of two sines. So I need to use the second identity because it's the product of two sine. Okay. Let me open a new page. Example 8. It's sine of 2t times sine of 4t. Okay, so the question is, you have sine of 2t times sine of 4t. Write this as a sum or difference. So because this is, look, what do you have? You have a multiplication of two sine function, a product of two sine function. So we need to use the middle identity. It's half of cosine of the difference of those two angles. So it's gonna be half of cosine of the difference of these two angles, so 2t minus 4t, okay? So cosine of the difference angle minus cosine of the sum of those angles minus cosine of the summation of those angles. So here I used product to sum identity, which means that we are given product of two trig function, product of two sine function, and we rewrite it as the summation or difference. Here is the difference. You see the difference of two trig functions. If you want, you can further simplify. This is gonna be half of cosine of negative 2t minus cosine of 6t. Again, because cosine is even function, so cosine of negative 2 is the same as cosine of 2t minus cosine of 6t. So that's it. You see? So we are able to, example 8, we were able to rewrite this product as the difference of two cosine function, cosine of 2t minus cosine of 6t. Another set of identities is the reverse. So going from summation to product. So suppose you have summation of two trig function. For example, summation of two sine or difference of two sine, summation of two cosine or difference of two cosine, and then we want to express it as the product. For example, suppose you have the summation of sine of two angles. It can be written as 2 times sine of, what is the angle here? It's the average. Take the average of those two angles times cosine of the difference divided by 2. So as you can see in this table, on the left side, you have sum or difference of two trig function. On the right side, you have their equivalent version in terms of product of two function. For example, the question says evaluate example 9. Let's look at example 9. Example 9. The question says evaluate cosine of 15, cosine of 15 degree minus cosine of 75. That's the question. Evaluate this difference. Okay, so what do I have here? I have the difference, right? The difference between two cosine function, and the angles are different. One of them has the angle of 15, the other has the angle of 75. Now look at the identities. So we are in the last format. You see, we have, what do we have? We have the difference of two cosine function, cosine of two angles. So I'm gonna just apply the sum to product last this identity, okay? So here I'm gonna apply the this is sum. This is sum to product identity for cosine. So it's gonna be what? It's gonna be it's gonna be negative 2. So it's gonna be negative 2 sine of the average of those angles, sine of the average, which means 15 plus 75 divided by 2 times sine of the difference of those angles divided by 2. Okay, so I just applied this identity, the last identity in this table, which gives the difference of, which gives a formula for the difference of two cosine function. And we rewrote it, we rewrite it as the product of two sine function. The difference is that the angles are different. So it's gonna be negative 2. Okay, look. What is the new angle? 15 plus 75. Oops. Look, 15 plus 75 is 19. Divided by 2 is 45. So it's gonna be sine of 45 degree times sine of, now 15 minus 75 divided by 2 is going to be negative 30. Negative 30 degree. Okay, because these are basic function, we know how to evaluate that. The question is evaluated. Now I know how to find the exact value. Sine of 45 degree is a square root of 2 over 2. Sine of negative 30, look, this is 30 and sine is half. But negative 30 degree is right here. So the sign is negative half. So this is going to be negative half. Okay, now you can simplify negative times negative. So it's going to be a square root of 2 over 2. So you see, we evaluated cosine of 15 minus cosine of 75 using one of the identity. What's given is the difference of these two cosine function. We rewrote that as the product of two sine function. And why this is good? You know why this is good? Because look, when we apply this, what is the original given angle? The original given angle is 15 degree. Do you know what is the exact value of cosine of 15? No. The given angle is 75. Do we know what is the exact value of the cosine of 75? No. But when we use this identity, the angles, we end up dealing with new angles. And these new angles are 45 and 30 degree. These are the angles that we know. We know what is the sine of 45. We know what is the sine of 30. That enables us to evaluate and find the exact value of this expression. So that's the application of this set of identity. It changed the angle, and the new angle is in a way that we know how to deal with that. The next one is just prove the identity. You have expression on the left. It's the difference of cosine over the summation of two sine function. So just apply these identities, the difference of two cosine and the summation of two sine, and then start simplifying. You get to the left side. Okay, I'm gonna show you number 11. Number 11 says solve this equation. So this equation contains trig functions. So let's look at this equation. So this is example 11. Example 11. Sine of pi t sine of pi t plus sine of 3 pi t sine of pi t plus 3 sine of 3 pi t equal cosine of pi t. Okay, so that's the equation. Okay, it says solve this equation for all solution between 0 and 2. So find all the t between 0 and 2. So find all the value of t between 0 and 2 such that it satisfies this equation. So look, what do we have here? On the right side, we have cosine. So okay, that's it. I'm going to leave it like that because I cannot simplify that further. But on the left side, what do we have? We have summation of two sine function, sine of an angle plus sine of another angle. So this, I have an identity for this. There is an identity here. The summation, look one more time, it's the summation of two sine functions. So the first identity. So I'm going to apply the first identity here. So this is the sum to product identity that I'm going to apply. So it's going to be 2. So this side is going to be 2 sine of average of those two angles, you see, average. So we add these two angles and then we divide it by 2 times cosine of the difference. So it's going to be this minus this angle divided by 2. So this is just the left side. Equal, now right side, cosine of pi t. Okay? So we can simplify. So on the left side, so this is just, so here we have the sum, and we changed it to product, the sum of two trig function. Now it's written as the product of two trig function. And we are able to simplify this further. So pi t plus 3 pi t is going to be 4 pi t divided by 2. And this is going to be negative 2 pi t divided by 2. What else? We can still simplify further, because this is going to be 2 pi t, and this is going to be this by this goes away, and cosine is an even function, so I can rewrite this as pi t times cosine of pi t, right? Okay. I would say to take everything on one side. This is just algebra. We want to solve this, right? So take everything on one side. Now, what is common in this, in here, is cosine of pi t is the common expression. So factor this from this equation. So from the first term, we are going to end up with 2 sine of 2 pi t, and here 1. So now that we factor it, so it's either the first one is equal to 0, so it's either cosine of pi t equal to 0, or this guy is equal to 0. So if this is 0, so pi t, so the angle, I mean, if cosine is 0, so that means the angle is either pi over 2, 3 pi over 2, and so on, right? So that means t, if you divide both sides by pi, so that means t is either half or 3 over 2. If you want, I can go further. So this is going to be 5 pi over 2, 7 pi over 2, and so on. And then t is going to be 5 over 2, 7 over 2, and so on. However, we should only accept t value between 0 and 2, only between 0 and 2. So the acceptable value is half, 3 over 2, 5 over 2 is 2.5. No, we don't accept the rest. So only these two from this element. And then the second factor, what this is going to give me? This is going to be 1 over 2. So that means the angle, okay, if sine of an angle is half, so that means that the angle is either pi over 6, pi over 6, 11 pi over 6, and so on, right? So if you divide, and maybe I write more. So it's, look, if it's half, so this is half, right? So it's either pi over 6, oh, sorry. If sine is half, so it's pi over 6, or this one. Sorry. This one. This is pi minus pi over 6. So it's going to be 5 pi over 6. Okay, so it's either 5 pi over 6, and then this is going to be, the next one is going to be 2 pi plus pi over 6, right? 2 pi plus pi over 6, and so on. 2 pi plus 5 pi over 6, and so on, right? So when we divide both sides by 2 pi, we get the value of t. So it's going to be 1 over 12, 5 over 12, Let me simplify this. This is gonna be 13 pi over 6. So 13 over 12. This is gonna be 12 plus 5, 17 pi over 6. So it's going to be 17 over 12 and so on. And we accept t's between 0 and 2. So this is acceptable, this is acceptable, this is acceptable, this is acceptable. And you can check if you have further solution. But the idea is that here is the big picture of the question. The idea is that we started with the sum to product identity, and then we started just simplifying and using algebra in order to factor it and find a solution. And you can also check it, check the work on your textbook. Okay. So yes, so when we get cosine of pi over t, we end up with the t value half and 3 over 2, which is the same as what we got here. We accepted the half, we accepted 3 over 2, and from the other factor, which we get sine of 2 pi over t is half, so that means we get the t values such as 1 over 12, 5 over 12, and so on. So we got 1 over 12, 5 over 12, and so on. You can, if you want to know further details, your textbook goes into more details. I just wanted to give you the big picture. Okay, that's all about this. So as you can see, we learned about sum and difference identity, product to sum identities, sum to product identities, and we saw the application of these identities. So now you should be able to do the exercises of this section. Thank you for watching this video. I'll see you in the next one.